Welcome back. Today we're going to talk about negative powers of 10 and scientific notation using negative powers of 10. Okay, so the first thing I want to talk about is when we look at powers of 10, let's explore them before we use them in scientific notation. So 10 to the 0 power, now again using our exponent rules, anything to the 0 power is 1. So 10 to the 0 power is just 1. Okay, 10 to the negative 1, well that's going to be 1 over 10 to the first power will just be 1/10. Okay. 10 to the negative 2, that's 1 over 10 squared or 1/100. Okay. 10 to the negative 3 is 1 over 10 to the third, so it's 1,000th. Okay. Notice with the exception of well, actually, they're all names of place values. So 1/10th, right? 100th, 1,000th, and 1 place. Those are all place values in our base 10 system. That's what it means. Our base 10 system means that every place value. So if I have a number here, I just make up a number. Every place value, we name them by powers of 10. This place value right here is going to be 10 to the 0 power. This place value right here is going to be 10 to the first power, or 10. That's in the tens place. This place value right here is 10 to the second power, or the hundredths place. Likewise, this is 1/10th, this is 100th, this is 1,000th, and this is 1/10,000th. Okay, so a number like this can be written in terms of every place value can be written in powers of 10. So this would be 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, and 10 to the negative 4, and so on. Okay, that's what it means when we have a base 10 system, is that every place value is a power of 10. Okay, so when we take a number and we multiply it by a power of 10, now right now I'm still not talking about scientific notation because none of these numbers start off in scientific notation. I just want to get us to understand what happens with a number as we decrease the power of 10 we're multiplying it by. So let's take the number 456. I'm going to make the number that I'm multiplying it by smaller and smaller and see what happens. Well, 456 times 10 to the 0, that's just 456 times 1, so that's just 456. Okay, now 456 times 10 to the negative 1, well, that's 456 times 1 over 10. Okay, so that's 456 if I put this over 1, right? It'd be 456 over 10, but we can actually do that division. It would be 45.6, so 45.6, because 456 divided by 10, you just move 1 decimal place into the left here. Well, the next one would be 456 times 1 over 100, which would be 456 times or 456 divided by 100. So when you're dividing a number by 100, you move it in 2 decimal places. Okay, so this would end up being 0.456. Whoops. Okay, so we moved it in, it would be 4.56. All right, if we multiply this one, it would be 456 times 1 over 1,000, which is equal to 456 divided by 1,000, which this is going to move the decimal place 3 spaces, 1, 2, 3. So this is going to get you 0.456. All right, so this right here, we can just jump 456 divided by 10,000, right? That's what we're going to get in the end. Well, if we're dividing by 10,000, we move the decimal place over 1, 2, 3, 4. Okay, so here it would be 0.0456, right? So notice what's the pattern is. right? If I have 0 in the exponent, I don't move any places, right? The decimal place remains where it always was. If I have -1, the result is going to be 1 decimal place to the left of where I started from. It started at 456. It now is at 45.6, so it's 1 to the left. If it's -2, it's going to be 2 to the left. If it's -3, it's going to be 3 to the left. And if it's -4, it's going to be 4 to the left of where it originally started. All right. So we're going to use that understanding when we talk about scientific notation. So going from scientific notation back into standard notation. Okay. So what we know about this number is we know that, so a number written as 6.357 times 10 to the -3, well, that's going to be 6.357 times 1 over 10 to the -3 would be 1,000th, right? Well, that's 6.357 divided by 1,000. And that's going to take the original point of the decimal place right here and move it over 3 spaces. 1, 2, 3. 1 for each power of 10. Well, in the end, the answer is I'm going to fill in these zeros, and the decimal place ends here. So it's going to be 0.006357. Okay? And that's how we can write it in standard form. So what I really want you to notice is that this might be a negative exponent, but remember, the answer never gets negative. It just gets very, very small. All right? So numbers that have negative powers of 10, numbers in scientific notation that have negative powers of 10, just end up being very small. They're not negative numbers. If I go from standard notation to scientific notation, I take the number and I want to bring the decimal place over. So remember, scientific notation is a number times 10 to a power, and a has to be greater than 1 and less than or equal to 10. So I'm trying to get a coefficient of a here that is between 1 and 10, but strictly less than 10. Oh, actually, sorry, it's the other way around. It's greater than or equal to 1, but strictly less than 10. Okay. So I'm looking for a number that's between 1 and 10, but less than 10. So I'm going to move the decimal place over a certain amount of time. I'm going to move it over 1, 2, 3, 4, 5, 6. So here I have 5.887. That's certainly between 1 and 10 and strictly less than 10. And then think about the power of 10 that I would need to use in order to get this back to this, right? Since I'm moving to the right here, in order to put it in scientific notation, that means that my exponent, my 10, is going to be negative. So we did 1, 2, 3, 4, 5, 6. So it's going to be 10 to the -6. Now let's see if that makes sense. We know that negative powers of 10 we multiply a number by negative powers of 10, it moves to the left a certain amount of times. So if these two numbers are equal and we go from scientific notation back to standard, I would move this decimal place to the left by 6 moves, and that's going to get me this. Okay? So the rule is if a number's between, if the standard notation number is between 0 and 1, to get it into scientific notation, you are going to have a negative power of 10. Okay? Whereas if the number is greater than 1, that's what we saw the other day, the number is greater than 1, then you're going to have a positive power of 10. And that's it for the lesson for today.